Hello, in this lecture we'll answer on two questions. In the first question we'll find out the area of square ABCD. In the second question we'll find out the size of this angle theta, that is inside triangle DOE. So we start with the first question. In the drawing we have square ABCD. We know that line segment AP equals to 5 units, line segment VP equals to 3 units, line segment CP equals to 6 units, and our mission is to find out the area of this square ABCD. So first of all, we'll do a construction. We'll extend side DC of square ABCD by a straight line. And from point P, we will draw perpendicular on the extended DC. So this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point P in the extended DC as N. In the next step we will do another construction from point B. From point B we will do perpendicular on PN. Again from point B we do perpendicular on PN. So this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and PN as M. In the next step, we define side BM as A. Again, we define side BM as A. That is to say, side BM equals to A units in its length. And we define side PM as B. Side PM as B. That is to say, side PM equals to B units in its length according to our definition. In the next step, we will implement the Pythagoras theorem on the green right triangle, triangle PBM. I'll repeat again, we will implement the Pythagoras theorem on the green right triangle, triangle PBM. Here by PT is abbreviation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So here the hypotenuse of the green right triangle, triangle PBM is PB. Therefore, the square of the hypotenuse is PB squared, and it must be equal to the sum of the surface of the perpendiculars. That is to say, it must be equal to BM squared plus PM squared. So, I repeat again. In the green right triangle PBM, according to the Pythagoras theorem, PB squared equals to BM squared plus PM squared. PB equals to 3 units according to what is given as the question. Therefore, PB squared is 3 squared, that is 9. And it is equal to BM squared. BM is A according to our definition, therefore BM squared is A squared plus PM squared. PM equals to B according to our definition, therefore PM squared will be equal to B squared. In conclusion, we found out that according to equation number 1, A squared plus B squared equals to 9. Okay. We know that all the angles inside a square are right angles, they are equal to 90 degrees. Therefore, those 4 angles in square ABCD are right angles. They are equal to 90 degrees. And those 4 angles are all equal to 90 degrees. So here we know that DC is one side of square ABCD, therefore it is absolutely a straight line. And we extended the straight line DC by straight line. In this way we got line segment CN, line segment DN. We got this line segment DN by extending the straight line by straight line. And when you extend a straight line by a straight line, the result must be a straight line, therefore DN is a straight line. So we can write down that DN is a straight line. So if we focus on the upper side of the straight line DN at point C, here the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So each angles we have at the upper side of DN at point C, this angle equals to 90 degrees, therefore the missing angle, this missing angle, must be also equal to 90 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. So in order to complete the sum of the angles on the upper side of DN at point C to 180 degrees, this angle must be also equal to 90 degrees. Okay, so actually we found out that inside quadrangle BMCN, inside this quadrangle we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So the fourth angle must be also equal to 90 degrees, according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. So in order to complete the sum of the angles in this quadrangle to 360 degrees, this angle must be equal to 90 degrees. Okay, so actually found out that quadrangle BMCN has 4 right angles, therefore it is a rectangle. Okay, so we focus on the lower side of line segment AM at point B. In the lower side of AM at point B, we have this angle that is equal to 90 degrees, plus this angle that is also equal to 90 degrees. 90 degrees plus 90 degrees is 180 degrees. That is to say, angle ABM equals to 180 degrees. Write it down, angle ABM equals to 180 degrees. And you actually know that any angle that is equal to 180 degrees, it is a straight line. Therefore, angle ABM is a straight line. Angle ABM is a straight line. So if angle ABM is a straight line, then line segment ABM is a straight line, and if line segment ABM is a straight line, then line segment AM is also a straight line. So going down that line segment AM is a straight line. So if line segment AM is a straight line, it means that triangle APM, this triangle is a right triangle. So here the green triangle is a right triangle. So we can implement the Pythagoras theorem on the green right triangle, triangle APM. Okay. So in the right green triangle, triangle APM, by PT is abbreviation for Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse of the right green triangle, triangle APM is AP, therefore the square of the hypotenuse is AP square, and it must be equal to the sum of the squares of the perpendiculars, that is to say it must be equal to PM square plus AM square. We will define the side length of square ABCD as x. Therefore, all of its sides, they will be equal to x units in their length. So according to the Pythagoras theorem in the right green triangle APM, AP square equals to PM square plus AM square. According to what is given as the question, AP equals to 5 units, therefore AP square is 5 squared, that is 25. And it is equal to PM square. PM equals to B, therefore PM square is B square. Plus AM square. What is the length of AM? It is very easy to see from the drawing that AM equals to A plus X. Again, AM equals to A plus X. So if AM equals to A plus X, it means that AM square will be equal to A plus X square. So in conclusion, we found out that according to equation number 2, 25 equals to b squared plus a plus x squared. Here we'll open the brackets on this side of equation number 2, and we get that according to equation number 2, 25 equals to b squared plus a plus x squared. A plus x squared equals to a squared plus x squared plus 2ax. In this equation, equation number 2, we have here a squared plus b squared. And according to equation number 1, we have already found out that a squared plus b squared equals to 9. Therefore, we can substitute a squared plus b squared in equation number 2 by 9. We do it now and we get that 25 equals to 9 plus x squared plus 2ax. Here we subtract 9 from this equation number 2, and we get that according to equation number 2, 25 minus 9 is 16, and it is equal to x squared plus 2ax. Here we subtract x squared from this equation number 2, and we get that according to equation number 2, 16 minus x squared equals to 2ax. Here we divide this equation number 2 by 2x, and we get that according to equation number 2, a equals to 16 minus x squared over 2x. We actually found the value of a in terms of x. Here we already found out that quadrilateral BMCN has 4 right angles. Therefore, quadrilateral BMCN is a rectangle. Because it has 4 right angles. Okay, but we also know that the opposite sides of a rectangle are equal to each other. That is to say, BM equals to CN. BM equals to CN, but we know that BM equals to A according to our definition, and from this equation A equals to BM equals to CN, we derive that CN is also equals to A. CN equals to A. And I feel that Cn equals to A. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we will get that BC equals to MN. BC equals to MN. But according to our definition, BC equals to X. So can I tell that BC equals to X? And from this equation, X equals to BC equals to MN, we derive that MN is also equals to X. MN equals to X. And I feel that Mn equals to X. In the next step, we'll implement the Pythagoras theorem in the right green triangle PCN. So in the right green triangle PCN, by P, T is a relation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle PCN is PC, therefore the square of the hypotenuse is PC squared. And it must be equal to the sum of the squares of the perpendiculars, that is to say it must be equal to Pn squared plus Cn squared. I repeat again, in the right triangle PCN, according to the Pythagoras theorem, PC squared equals to Pn squared plus Cn squared. According to what is given as the question, PC equals to 6, therefore PC squared is 6 squared, that is 36, and it is equal to Pn squared. What is the length of Pn? It is very easy to see from the drawing that Pn equals to b plus x, therefore Pn squared is b plus x squared. Plus Cn squared. Cn equals to a, therefore Cn squared will be equal to a squared. So in conclusion, according to equation number 3, we found out that 36 equals to b plus x squared plus a squared. Here we open the brackets on this side of equation number 3 and we get that according to equation number 3, 36 equals to b squared plus x squared plus 2 times b times x plus a squared. So in this equation number 3, we have here a squared plus b squared, and according to equation number 1, a squared plus b squared equals to 9. Therefore, we'll substitute a squared plus b squared in this equation number 3 by 9, and we get that 36 equals to 9 plus x squared plus 2bx. Here we subtract 9 from this equation number 3, and we get that according to equation number 3, 36 minus 9 is 27. That is equal to x squared plus 2bx. Here we subtract x squared from this equation number 3, and we get that according to equation number 3, 27 minus x squared equals to 2bx. So here we divide this equation number 3 by 2x, and we'll get that according to equation number 3, b equals to 27 minus x squared over 2x. So actually we have the values of a and b in terms of x, and we know that according to equation number 1, squared plus b squared equals to 9. So we have already found out that a equals to 16 minus x squared over 2x. So if we square this expression, we get the value of a squared plus b squared. We already found out that b equals to 27 minus x squared over 2x, and if we square this expression, we get the value of b squared. So a squared plus b squared according to equation number 1 equals to 9. Here we'll open the brackets of those two expressions, and we get that according to equation number 1, 16 minus x squared squared is equal to 16 squared, that is 256, plus x squared squared is x to the power of 4, minus 2 times 16 is minus 32, times x squared. And here, those two expressions have the same denominator, that is actually 4x squared. Therefore, we will add the numerator of the first expression to the numerator of the second expression. Because they have the same denominator, we can do it. And we get that 27 minus x squared squared is equal to 27 squared, that is 729, minus 2 times 27 is minus 54, times x squared, plus x squared squared is plus x to the power of 4. And is equal to 9. According to this equation number 1. $256 plus 729 is 985. X to the power of 4 plus x to the power of 4 is 2 times x to the power of 4. And finally, minus 32x squared minus 52x squared is minus 86x squared, divided by 4x squared is equal to 9. Here we multiply this equation number 1 by 4x squared, and we get that according to equation number 1, two times x to the power of 4 minus 86x squared plus 985 equals to 4x squared times 9 is 36x squared. So here we subtract 36x squared from this equation number 1, and we get that according to equation number 1, two times x to the power of 4 minus 86x squared minus 36x squared is minus 122x squared plus 985 equals to 0. Okay, so here we define z as x squared, z equals to x squared according to our definition. And if z equals to x squared, it means that z squared will be equal to x to the power of 4. Therefore, this expression in total will be equal to 2z squared. So we substitute 2 times x to the power of 4 by 2z squared. And we have here minus 122 x squared. Minus 122 x squared. Here we substitute x squared by z, and we get in total that this expression equals to minus 122z plus 985 equals to 0. Okay, so we got here a quadratic equation, 2z squared minus 122z plus 985 equals to 0. It is a quadratic equation. And the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. When we find out the value of x according to the following formula, x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. Okay. In our specific quadratic equation, the coefficient a equals to 2. The coefficient a equals to 2. The coefficient b equals to minus 122. And the coefficient c equals to 985. And the variable that we are looking for is z. So we put the value of z inside and substitute z by x, and we put the data inside this formula, and we get the value of the values of z, because here x equals to z. And we get that z equals to minus b. b is minus 122, therefore minus b is minus 122, that is plus 122, plus minus square root of b squared. b is minus 122, therefore b squared is minus 122 squared, that is actually equals to 14,884 minus 4 times a equals to 2, so minus 4 times 2 is minus 8, times c is 985, so minus 8 times 985 is equal to 7,880, all divided by 2a. a is 2, so 2a is 2 times 2, that is 4. So here we found out that z equals to 122 plus minus 14,884 on 7,880 is 7,004. So inside the root we have only 7004 is left, all divided by 4. So here I found out that Z equals to 122 plus minus, and the square root of 7004 is equal to 83.6899 over 4. So here we will have two solutions that are possible for Z. The first solution for Z is that Z equals to 122 plus 83.6899 over 4. So Z equals to 122 plus 83.6899 is 205.6899, and if we divide it by 4, we get that Z equals to 51.4224. So here we found out that according to the first solution for Z, Z equals to 51.4224. But what is Z? Z, it is actually equals to x squared according to our definition. And we found out that Z equals to 51.4224. So we take the root out of this equation in order to find out the value of x itself, because here this number equals to x squared. So the square root of 51.4224, that is to say x equal to 7.17 units. So we actually found out that here AB that is equal to x is equal to 7.17 units, and it is impossible that x equals to 7.17 units, and I will explain you why. Because if we focus on the right green triangle, triangle APM, in the right green triangle, triangle APM, the hypotenuse AP equals to 5 units. And we know that in any right triangle, the hypotenuse is the biggest side. So if you focus on this side triangle, triangle APM, the hypotenuse AP must be bigger than AM. AP is bigger than AM. So if AP is bigger than AM, let alone that it will be bigger than AB, that is part of AM. So here we found out that AP is bigger than AB, that is equal to x. Repeat again. We actually found out that AP, the hypotenuse AP that is equal to 5 is bigger than AB that is equal to x. So from this inequality, we'll get that x is less than 5 units. But we just right now found out that x equals to 7.17 units, that is bigger than 5 units. Okay, we have here a contradiction, and due to the contradiction, we conclude that this solution is incorrect solution, and we focus on the second solution for Z. According to the second solution for Z, Z equals to 122 minus 83.6899 over 4. So Z equals to 122 minus 83.6899 is 38.6899, and if we divide it by 4, we get that Z equals to 9.5775. Okay. But according to our definition, Z equals to x squared. And what is the area of square ABCD? It is exactly equals to x squared. That is to say, the area of square ABCD that is equal to x squared that is equal to Z, it is equal to 9.5775 square units. Here we take out of this number in order to verify that x is not greater than the hypotenuse AP that is equal to 5, and indeed if we take out of this number 9.5775, we get that x equals to 3.09 units, that is of course less than 5 units, that is the length of the hypotenuse. So found out that the area of square ABCD equals to 9.577 square units. We finish with the first question. In the next step, I will present to you the second question. In the drawing, we have a right triangle, triangle ABC, angle ABC equals to 90 degrees. Inside the right triangle ABC, we have a circle, and inside the circle, we have here triangle DOE. Our mission is to find out the size of this angle, angle theta, in triangle DOE. It is given us the question that line segment AD equals to line segment EC, and line segment DE is twice as long as AD, and DE is also twice as long as EC. That is to say, AD equals to EC equals to BE over 2. Again, our mission is to find out the size of this angle, angle theta. Okay, so first of all, we will define DE as 2A. That is to say, DE equals to 2A according to our definition. And from the equation that has been given us in the question, AD equals to EC equals to DE over 2. Here we substitute DE by 2A. Two A over 2 is A. So in conclusion, we found out that AD equals to EC equals to A. From this equation, we get that AD equals to EC equals to A. That is to say, AD equals to A units, and EC is also equals to A units. In the next step, I present to you a new rule. It is not new rule, but rule number 4. According to rule number 4, the perpendicular from the center of a circle to a chord bisects the chord. The center of the circle is at point O. We have here chord CD, and according to rule number 4, the perpendicular OM to chord CD bisects chord CD. That is to say, according to rule number 4, CM equals to MD. And it bisects chord CD, it means that it divides it into two halves. CM equals to CD over 2, and MD also equals to CD over 2. We can implement this rule number 4 in our drawing. From the center of the circle, that is to say from point O, we will draw perpendicular on chord DE of the circle. So actually, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and DE as T. So here, actually, according to rule number 4, the perpendicular OT bisects chord DE. That is to say, DT equals to TE, DT equals to TE, DT equals to TE according to rule number 4. And each part is half of DE. That is to say, DT equals to DE over 2, and TE is also equals to DE over 2. But according to our definition, DE equals to 2A. So we have here 2A over 2 is A. So in conclusion, we found out that for this long equation, you can derive that DT equals to TE, that is equal to A. That is to say, DT equals to A, and TE is also equals to A. Okay? In the next step, we define the point of tendency of tangent AB with this circle SM. We define the point of tendency of tangent BC with this circle as N. We will join points O and M together by a straight line. Point O is the center of the circle. Point M is the point of the circle itself, therefore OM is the radius of the circle that we will define as R, or M equals to R. And we have here the radius OM, it is drawn to the point of tendency, therefore according So rule number 1, that the tangent to a circle is perpendicular to the radius drawn to its point of tendency. This angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Likewise, we join points O and M together by a straight line. Again, point O is the center of the circle, point N is the point of the circle itself, therefore ON is the radius of the circle that is equal to R according to our definition. And again, we have the radius ON that is drawn to the point of tendency, therefore according to rule number 1, this angle equals to 90 degrees and this angle also equals to 90 degrees. So inside quadrilateral OMBN we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees. So inside quadrilateral OMBN we have 4 right angles, therefore quadrilateral OMBN is a rectangle. So I write it down, quadrilateral OMBN is a rectangle because it has 4 right angles. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, rectangle OMBN, MO equals to BN. MO equals to BN. But we already found out that MO equals to R. It is the radius of the circle. And from this equation, R equals to MO equals to Bn, we derive that Bn is also equals to R. Bn is equal to R. So we can write here that Bn equals to R. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we get that ON equals to MB. ON equals to MB. But we have already found out that ON equals to R, it is the radius of the circle. And from this equation, R equals to ON equals to MB, we derive that MB is also equals to R. MB is also equals to R. So you can write down here that MB equals to R. And because of the fact that quadrilateral MOBN has 4 equal sides that are all equal to R, we derive that MOBN is a square and not a rectangle. So I write it down. Quadrilateral MOBN is a square. So the next step, I present to you rule number 10, and we implement rule number 10 in our drawing. Here we have the external point P. From the external point P, we have tangent PA, that is tangent to the circle at point A. Point A is the point of tendency. And we have this straight line that intersects with the circle at point B and C. So if this is the data that has been given to us, then the following equation is true, that PA squared equals to PB times PC. Again, PA squared equals to PB times PC. We actually can implement rule number 10 in our drawing. So if we focus at point C, external point C, from the external point C we have tangent Cn to the circle, and we have the straight line, this straight line that intersects with the circle at point C Indeed, according to rule number 10, we get here that Cn square equals to Ce times Cd. Again, Cn square equals to Ce times Cd. Write it down, Cn square equals to Ce times Cd. Repeat again. If we focus on point C, according to rule number 10, Cn square equals to Ce times Cd. Okay. So Cn square equals to Ce. C equals to A, therefore we substitute Ce by A times Cd. What is the value of Cd? It is very easy to say from the domain that Cd equals to A plus A plus A, that is 3A, so we substitute Cd by 3A. So in conclusion, I found out that according to rule number 10, Cn square equals to A times 3A. A times 3A is 3A square, so Cn square equals to 3A square. Here we take out all of this equation and we get that Cn equals to the square root of 3A square. The square root of A square is A, and the square root of 3 is the square root of 3. So in total we found out that the square root of 3A square is square root of 3 times A. Here we found out that Cn equals to the square root of 3 times A. So we can write down here that Cn equals to the square root of 3 times A. Likewise, we'll focus on the external point A. On the external point A, we have tangent AM to the circle, and we have the straight line that intersects with this circle at point D and then point E. Therefore, we can implement here rule number 10. According to rule number 10, we get that AM square AM square equals to AD times AE. Repeat again. If we focus on the external point A, according to rule number 10, we get that AM square equals to AD times AE. So AM square equals to AD. AD is A, so we substitute AD by A times AE. AE equals to A plus A plus A, that is 3A, so we substitute AE by 3A. So, in conclusion, we found out that AM square equals to A times 3A, that is to say AM square, A times 3A is 3A square. AM square equals to 3A square. Here we take out all of this equation and we get that AM equals to the square root of 3 times A. So I found out that AM is also equals to the square root of 3 times A. So we can write here that AM is also equals to the square root of 3 times A. step, I copy the right triangle, triangle ABC in a new page, and we analyze the right triangle, triangle ABC. What is the length of side AB? Side AB, it is very easy to see from a drawing that side AB equals to the square root of 3 times A plus R. And what is the length of side BC? It's very easy to see from a drawing, but side BC is also equals to the square root of 3 times A plus R. And what is the length of the hypotenuse AC? Again, it is very easy to see that the hypotenuse AC equals to A plus A plus A plus A, that is 4A. So actually, this is the right triangle, triangle ABC. Is the code of the original drawing. Side AB and side BC, they are both equal to square root of 3 plus A, square root of 3 times A plus R, therefore they are equal to each other. So in triangle ABC, those two sides are equal to each other, and we have the rule that in front of equal sides in the triangle, they are equal. In front of equal sides in a triangle, there are equal angles. So in front of those two sides, we have those two angles that are equal to each other. So if this angle equals to alpha, then this angle must be also equal to alpha because of the fact that they are equal to each other. They are located in front of equal sides, therefore they are equal to each other. So this angle equals to 90 degrees, therefore the other two angles must be equal to 90 degrees in order to complete the sum of the angles in the right triangle ABC to 180 degrees. Those two angles must be equal to 90 degrees. That is to say, I found out that alpha plus alpha in total must be equal to 90 degrees. Alpha plus alpha is 2 alpha, that is equal to 90 degrees. Here we divide this equation by 2 and we get that alpha equals to 45 degrees. Okay, here alpha equals to 45 degrees. Those both angles are equal to 45 degrees. So we actually found out that triangle ABC is not only a right triangle, but it is also an isosceles triangle. We'll focus and continue to focus on the right triangle, triangle ABC. In the right triangle, triangle ABC, it is very easy to see if we focus on this angle that cosine 45 degrees is equal to BC over AC. Again, cosine 45 degrees equals to BC over AC. BC equals to the square root of 3 times A plus R, and AC equals to 4A. Cosine 45 degrees is equal to 1 over square root of 2, that is equal to square root of 3 times A plus R over 4A. Here we will multiply this equation by 4A and we get that 4A over square root of 2 equals to square root of 3 times a plus r. Here we substitute 4 by 2 times 2 and we get that 2 times 2 over square root of 2, 2 times 2 times a over square root of 2 equals to square root of 3 times a plus r. Okay, again, I found out that 2 times 2 times a over square root of 2 equals to square root of 3 times a plus r. We substitute one of the 2's by square root of 2 times square root of 2 and we get that 2 times square root of 2 times square root of 2 over square root of 2 times a equals to square root of 3 times a plus r. Here we have square root of 2 in the numerator and square root of 2 in the denominator, so square root of 2 will get cancelled and we left only with 2 times square root of 2 times a, that is equal to square root of 3 times a plus r. Here we subtract square root of 3 times a from this equation and we get that 2 times square root of 2 times a minus square root of 3 times a equals to r. Here we take a as a common factor out of those two expressions and we get here what is left from 2 times square root of 2 times a after we took from it a as a common factor. What is left is actually 2 times square root of 2. What is left from minus square root of 3 times a after we took from it a as a common factor, what is left is actually minus square root of 3. That is equal to r. In conclusion, we found out that the radius of the circle is equal to a times 2 times square root of 2 minus square root of 3. In the next step, I will copy the right great triangle DOT in the new page and we analyze triangle DOT, but here, before that, we know that point O is the center of the circle, point D is the point of the circle itself, therefore DO is the radius of the circle that is equal to R. So actually, this is the right triangle DOT that I copied from the original drawing. DOT. In the right triangle DOT, it's very easy to see from the drawing that cosine theta equals to dt over do. Again, cosine theta equals to dt over do. I write it down. Cosine theta equals to dt over do. dt equals to a and do equals to r. So, in conclusion, we found out that cosine theta equals to a over r. Cosine theta equals to a over r. That is to say, cosine theta equals to a, and we have already found out that r equals to a times 2 times square root of 2 minus square root of 3, so we substitute r by a times 2 times square root of 2 minus square root of 3. So here we have a in the numerator and a in the denominator, so a will get cancelled, and after we cancelled a, we left only with cosine theta that is equal to 1 over 2 times square root of 2 minus square root of 3. Our mission is to find out the value of theta itself. In order to find out the value of theta itself, we'll operate the opposite function of cosine, that is cosine minus 1, on the result, that is 1 over 2 times square root of 2 minus square root of 3. In this way, we get the value of theta itself. Again, we operate the opposite function of cosine, that is actually cosine minus 1, on the result, that is 1 over 2 times square root of 2 minus square root of 3. In this way, we get the value of theta itself. Okay? And cosine minus 1, the opposite function, if you operate it on 1 over 2 times square root of 2 minus square root of 3, we get that this expression equals to 24.203 degrees, that is equal to theta. So in conclusion, we found out that the size of angle theta is 24.203 degrees. Okay, here the size of this angle theta is 24.203 degrees. We finished with the second question. In the next step, I'll summarize the lecture. I'll start with the first question. So, in the drawing, we have a square ABCD. We know that line segment AB equals to 5 units, line segment BP equals to 3 units, line segment PC equals to 6 units, and our mission is to find out the area of this square ABCD. So first of all, we did the construction. We extended side DC of square ABCD by a straight line, and from point P we draw perpendicular on the extended DC. So this angle equals to 90 degrees according to our construction. In the next step, we did another construction. From point B Here we define the touching point of the perpendicular from point P and extended the CSN. And the second construction that we did from point D, we do perpendicular on PN. Again, from point B, we do perpendicular on PN. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and PN as M. Then we define side PM as B, we define side BM as A, and we implemented the Pythagoras theorem on the right green triangle, triangle PBM. On the right green triangle, triangle PBM, PB square equals to PM square plus BM square. Again, the right green triangle, triangle PBM, PB square equals to BM square plus PM square. Here, PB equals to 3 units, therefore PB square is 3 squared, that is 9, and it is equal to PM square. PM equals to A according to our definition, therefore PM square is A square, and PM equals, it is BM that is equal to A, therefore PM square equals to A square. PM equals to B, therefore PM square is B square. So in conclusion, we found out that according to equation number 1, 9 equals to A square plus B square. Okay, and we also know that all the angles inside the square are right angles, so in square ABCD we have 4 right angles. And here we did the construction here, we extended side DC by a straight line. DC is the side of a square, it is absolutely a straight line. And when you extended the straight line DC by a straight line, the result is DE, DN, that is must be also a straight line, because when you extend a straight line by a straight line, the result must be a straight line. So DN is a straight line. And if you focus on the upper side of the straight line DN at point C, here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have on the upper side of DN at point C? We have this angle that is equal to 90 degrees plus the missing angle. In total, they must be equal to 180 degrees. So this angle must be also equal to 90 degrees. In order to complete the sum of the angles on the upper side of DN at point C to 180 degrees, this angle must be also equal to 90 degrees. So in quadrilateral BMCN, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Okay, so we found out inside quadrilateral BMCN we have 4 right angles. Then we focused on a segment line AM. If we focus on the lower side of segment line AM at point B, this angle equals to 90 degrees and this angle equals to 90 degrees. 90 degrees plus 90 degrees is 180 degrees. So angle ABM equals to 180 degrees. And therefore angle ABM is a straight line. So if angle ABM is a straight line, then line segment ABM is a straight line, and if line segment ABM is a straight line, then line segment AM is also a straight line. And if line segment AM is a straight line, then shape AMP is a right triangle. So we implement the Pythagoras theorem on the right triangle, triangle APM. On the right triangle, triangle APM, AP square equals to PM square plus AM square. Repeat again, the right triangle, triangle APM, AP square equals to PM square plus AM square. AP equals to 5, therefore AP square is 5 square, that is 25. And it is equal to PM square. PM is B, therefore PM square is B square plus AM square. AM equals to X plus A, therefore AM square is X plus A square. So in conclusion, we found out that according to equation number 2, 25 equals to B square plus A square. So we open the brackets on this side of equation number 2 and found out that according to equation number 2, 25 equals to B square plus A square plus X square plus 2AX. So in equation number 2 we have B square plus A square, but according the equation number 1, we have already found out that b squared plus a squared equals to 9. Therefore, we can substitute b squared plus a squared by 9 in equation number 2. We did it, and we got that 25 equals to 9 plus x squared plus 2ax. We subtracted 9 from this equation, equation number 2, and found out that 25 minus 9 is 16, that is equal to x squared plus 2ax. Here we subtracted x squared from this equation, equation number 2, and found out that 16 minus x squared equals to 2ax. Here we divided this equation by 2x, and we found out that a equals to 16 minus x squared over 2x. So we found out the value of a in terms of x. Then we have already found out that quadrilateral BMCN is 4 right angles, therefore quadrilateral BMCN that has 4 right angles is a rectangle. Here quadrilateral BMCN is a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say BM equals to CN. But here, according to our definition, BM equals to A. So from this equation A equals to BM equals to Cn, we derive that Cn is also equals to A. Cn equals to A. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we get that BC equals to Mn. But BC equals to X. So, therefore, from this equation, x equals to bc equals to mn, we derive that mn is also equals to x. Mn equals to x. Then we implemented the Pythagoras theorem on the right big green triangle, triangle PCN. On the right big triangle PCN, we get that PC squared equals to Pn squared plus Cn squared. Again, PC squared equals to Pn squared plus Cn squared. PC squared equals to Pn squared plus Cn squared. PC equals to 6, therefore PC squared is 6 squared, that is 36. That is equal to Pn squared. Pn equals to b plus x, therefore Pn squared is b plus x squared plus Cn squared. Cn is a, therefore Cn squared is a squared. So, in conclusion, we found out that according to equation number 3, 36 equals to b plus x squared plus a squared. Here we open the brackets on this side of equation number 3, and we found out that according to equation number 3, 36 equals to b plus x squared equals to b squared plus x squared plus 2bx plus a squared. In equation number 3, we have b squared plus a squared, that is equal to 9 according to equation number 1, therefore we can substitute b squared plus a squared in equation number 1 by 9. We did it when we got that 36 equals to 9 plus x squared plus 2bx. We subtracted 9 from this equation and found out that 36 minus 9 is 27, that is equal to x squared plus 2bx. Here we subtracted x squared from this equation, equation number 3, and we found out that 27 minus x squared equals to bx. Here we divided this equation, equation number 3 by 2x, and found out that 27 minus x squared over 2x equals to b. So we have the values of a and b in terms of a, in terms of x. Okay. And according to equation number 1, we've already found out that a squared plus b squared equals to 9. A is equals to 16 minus x squared over 2x. If we square this expression, we get a squared. B is 27 minus x squared over 2x, so if you square this expression, we get b squared. So a squared plus b squared equals to 9 according to this equation, equation number 1. We open the brackets of those two expressions, and we found out that 16 minus x squared equals to 16 squared, that is 256, plus x squared squared, that is x to the power of 4, minus 2 times 16 is minus 32, times x squared. And because of the fact that those two expressions have the same denominator, we can add the numerator of this expression to the numerator of this expression. We did it when we got that 27 minus x squared is equal to 27 squared, that is 729, minus 2 times 27 is minus 54 times x squared, plus x squared squared, that is x to the power of 4 over 4x squared equals to 9. Here 256 plus 729 is 985, x to the power of 4 plus x to the power of 4 is 2 times x to the power of 4, and minus 32x squared minus 54x squared is minus 86x squared divided by 4x squared equals to 9. Here we multiply this equation number 1 by 4x squared, and we found out that 2x squared here, actually we have here 2x squared, here we multiplied the equation by 4x squared, and we found out that 2x squared minus 86x squared plus 985 equals to 36x squared, because 4x squared times 9 is 36x squared. Here we subtracted 36x squared from this equation number 1, and we found out that according to equation number 1, 2 times x to the power of 4, and here minus 86x squared minus 36x squared is equal to minus 122x squared plus 985 equals to 0. Here we define z as x squared, so if z equals to x squared, it means that z squared will be equal to x to the power of 4, therefore this expression in total will be equal to 2z squared. And we have minus 122, x squared equals to z, so we substitute x squared by z. So this expression equals to minus 122z plus 985 equals to 0. So we have the quadratic equation 2z squared minus 122z plus 985 equals to 0. So this is the quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we'll find out the value of x according to the following formula: x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, the coefficient a equals to 2, the coefficient b equals to minus 122, and the coefficient c equals to 985. So those are the three coefficients of our specific quadratic equation. We put the data inside the equation for x, and we found out the value of z, because here z equals to x, and we found out that z equals to minus b, b is minus 122, therefore minus b is minus 122, that is plus 122, plus minus square root of b squared. B is minus 122, therefore b squared is minus 122 squared, that is 14,884, minus 4 times a is 2, so minus 4 times 2 is minus 8, times c is 985, and minus 8 times 985 equals to 7,880 divided by 2a. A is 2, so 2 times a is 4. So here we found out that z equals to 182 plus minus 14,884 minus 7,880 is 7,004. So inside the root we left only 7,004 divided by 4. The square root of 7,004 is 83.6899. So we have here two solutions that are possible for z. Z equals to 122 plus minus 83.6899 over 4. The first solution for z is that z equals to 122 plus 83.6899 over 4, and 122 plus 83.6899 is 205.6899, and if we divide it by 4, we get that z equals to 51.4224. So we found out that z equals to 51.4224. But what is z? Actually, z, according to definition, is equal to x squared, and we found out that z equals to 51 0.4224. If we take a root out of this equation, we get the value of x. Because this expression, this number equals to x squared. So the square root of x squared is x. So the square root of 51.4224 is 7.17 units. So I found out here that AB that is equal to x equals to 7.17 units, and it is impossible that x equals to 7.17 units, and I will explain you why it is impossible. Why? Because if you focus on the right triangle APM, the right triangle APM, the hypotenuse AP equals to 5 units. And we know that the hypotenuse in any right triangle is the biggest side. That is to say, AP is bigger than AM. If AP is bigger than AM, let alone that AP is bigger than AB, that is part of AM. So I found out that AP that is equal to 5, the hypotenuse equals to 5, it is bigger than AB that is equal to x. Here, in the right triangle APM, we found out that the hypotenuse AP that is equal to 5 is bigger than AB that is equal to x. From this inequality, we will get that x is less than 5 units. While according to the solution, we found out that x equals to 7.17, that is greater than 5 units. So we have here a contradiction. Due to the contradiction, we cancel this possibility, that is to say, z cannot be equal to 51.4224. And we left only with the second solution for the quadratic equation of z. The second solution is z equals to 122 133.6899 over 4. 122 minus 83.6899 is 38.6899, and if we divide it by 4, we get that z equals to 9.5775. So here we found out that z that is equal to x squared equals to 9.5775, but I'm looking for the area of the square ABCD. What is the area of square ABCD? It is equal exactly to x squared. Well, and we have already found out that x squared equals to z, that is equal to 9.5775 square units. That is to say, the area of square ABCD equals to 9.5775 units, and we took a root out of this equation in order to verify that x is less than the hypotenuse AP, and indeed x equals to 3.09, that is less than 5 units. Okay, so we found out that the area of this square ABCD equals to 9.5775 square units. We finished with the first question. In the next step, I presented to you the second question. So in the drawing, we have a right triangle ABC. Inside the right triangle ABC, we have a circle, and inside the circle, we have triangle DOE. We are looking for this angle theta. It's given us the question that AD equals to EC, and DE is twice as long as AD, DE is also twice as long as EC. That is to say, AD equals to EC equals to DE over 2. So here we define DE as 2A, and according to the equation that has been given to us, AD equals to EC equals to DE over 2. DE is 2A, so we substitute DE by 2A, and we got here 2A over 2 is A. So in conclusion, we found out that AD equals to EC equals to A. That is to say, AD equals to A, and EC is also equals to A. Then I presented to you rule number 4. According to rule number 4, the perpendicular from the center of a circle to a chord, bisect the chord. We have the perpendicular OM from the center of the circle, that is O, bisect chord CD according to rule number 4. That is to say, CM equals to MD, and CM equals to CD over 2, and MD is also equals to CD over 2. Implemented rule number 4 in our drawing. In our drawing, from point O, that is the center of the circle, we draw perpendicular on chord DE. According to rule number 4, dt equals to TE, and dt equals to D over 2, and TE is also equals to T over 2. Here, dt equals to TE, and each part is equal to D over 2. DE is 2A, so 2A over 2 is A. So, in conclusion, found out that dt equals to TE equals to A. That is to say, dt equals to A, and TE is also equals to A. Then we defined the point of tendency of tangent AB with this circle as M. We define the point of tendency of tangent BC with this circle as N. Then we join points O and M together by a straight line. Point O is the center of the circle, point M is the point of the circle itself, therefore OM is the radius of the circle that we define as R. So OM equals to R. We have the radius OM that is known to the point of tendency, therefore this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule number 1. Likewise, we join points O and N together by a straight line. Point O is the center of the circle, point N is the point of the circle itself, therefore ON is the radius of the circle that is equal to R. Then we have the radius ON that is drawn to the point of the tendency, therefore this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule number 1. So inside quadrilateral MOBN, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. Therefore, quadrilateral MOBN that has 4 right angles is a rectangle. Quadrilateral MOBN is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. MO, that is to say, MO equals to BN. But MO equals to R according to what we have already found out. So from this equation, R equals to MO equals to Bn, we will derive that Bn is also equals to R. Here Bn is also equals to R. Likewise, according to the same rule that the opposite sides of rectangle are equal to each other, we get that MB equals to ON. MB equals to ON, but we already found out that ON equals to R. So from this equation, R equals to ON equals to MB, we will derive that MB is also equals to R. Here MB equals to R, therefore we found out that quadrilateral MOBN is not a rectangle but a square because all of its sides are equal to each other and are equal to R. Then I presented to you rule number 10, we implemented rule number 10 in our drawing. According to rule number 10, if we have the external point P, from the external point P we have tangent PA that is tangent to this circle at point A, and we have the straight line that intersects with the circle at points B and C. So if this is the data that has been given to us, then PA square equals to PB times PC. Again, PA square equals to PB times PC. Okay, implemented rule number 10 at point C. At point C we have tangent CN and the straight line that intersects with the circle at point E and D. Therefore, according to rule number 10, Cn square equals to Ce times Cd. Again, Cn at point C, Cn square equals to Ce times Cd. So here, Cn square equals to Ce is A, so we substitute C by A, and CD is A plus A plus A, that is 3A, so we substitute CD by 3A. So in conclusion, found out that Cn square equals to A times 3A. A times 3A is 3A square. So in conclusion, found out that Cn square equals to 3A square. We took out of this equation and found out that Ca equals to square root of 3 times A. Cn. Here Cn equals to square root of 3 times A. Likewise, we focus on the external point A. From the external point A, we have tangent AM, and we have this straight line that intersects with the circle at point D and at point E. Therefore, according to rule number 10, we get that AM square equals to AD times AE. Again, AM square equals to AD times AE. Repeat again, in the start point A, AM square equals to AD times AE. AD equals to A, so we substitute AD by A. AE equals to A, that is 3A, so we substitute AE by 3A. In conclusion, found out that AM square equals to A times 3A, that is 3A square, so AM square equals to 3A square. We took out of this equation and found out that AM equals to square root of 3 times A. Here, AM equals to square root of 3 times A. Then I copied the right triangle, triangle ABC, and in your page you analyze triangle ABC. This is the right triangle, triangle ABC that I copied from original drawing. In the right triangle ABC, it's very easy to see that side AB equals to square root of 3 times A plus R. Side BC is also equal to square root of 3 times A plus R. And the hypotenuse AC equals to A plus A plus A plus A, that is 4A. Okay? So here, side AB and side BC, they are both equal to square root of 3 plus A, square root of 3 times A plus R, therefore they are equal to each other. And we have the rule that in front of equal sides in the triangle, there are equal angles. So those two angles that are located in front of equal sides must be equal to each other. So if one angle is alpha, then the other angle must be also equal to alpha because of the fact that they are equal to each other. Okay? And this angle equals to 90 degrees, therefore the other two angles must be also equal to 90 degrees in order to complete the sum of the angles in the right triangle, triangle ABC, 280 degrees. Those two angles must be also equal to 90 degrees. That is to say, alpha plus alpha must be equal to 90 degrees. Alpha plus alpha is 2 alpha, that is equal to 90 degrees. We divided this equation by 2 and found out that alpha equals to 90 degrees over 2, that is 45 degrees. So each angle is equal to alpha. So in the right triangle, triangle ABC, if we focus on this angle, cosine 45 degrees equals to BC over AC. Again, cosine 45 degrees equals to BC over AC. BC is equal to square root of 3 times A plus R, AC equals to 4A. And cosine 45 degrees equals to 1 over square root of 2. So in conclusion, we found out that 1 over square root of 2 equals to square root of 3 times A plus R over 4A. We multiplied this equation by 4A and we found out that 4A over square root of 2 equals to square root of 3 times A plus R. Then we substituted 4 by 2 times 2 and found out that according to this equation, 2 times 2 times A over square root of 2 equals to square root of 3 times A plus R. Here we substituted one of the 2's by square root of 2 times square root of 2 and we found out that 2 times square root of 2 times square root of 2 over square root of 2 times A equals to square root of 3 times A plus R. Here we have square root of 2 in the numerator and square root of 2 in the denominator, so square root of 2 will get cancelled and we left only with 2 times square root of 2, that is equal to square root of 3 times A plus R. Here we subtracted square root of 3 times A for this equation and found out that according to this equation, 2 times square root of 2 times A minus square root of 3 times A equals to R. We took A as a common factor out of those two expressions. What is left from 2 times square root of 2 times A after we took from it A as a common factor? What is left is actually 2 times square root of 2, and what is left from minus square root of 3 times A after we took from it A as a common factor? What is left is actually minus square root of 3. So in conclusion, found out that the radius of the circle equals to A times 2 times square root of 2 minus square root of 3. Then I copied the right plane triangle, triangle DTO in a new page and analyze triangle DTO. Here point O is the center of the circle, point D is the point of the circle itself, therefore OD is the radius of the circle that is equal to R. So this is the right triangle, triangle DOT that I copied from the original drawing. in this right triangle, triangle DOT, it is very easy to see that cosine theta equals to dt over do. Again, cosine theta equals to dt over do. Cosine theta equals to dt over do. dt equals to a, do equals to r. So in conclusion, we found out that cosine theta equals to a over r, and we already found out that r equals to a times 2 times square root of 2 minus square root of 3. So we substitute r by a times 2 times square root of 2 minus square root of 3. And we got here this expression cosine theta equals to a over a times 2 times square root of 2 minus square root of 3. We have a in the denominator and a in the denominator, so a will get cancelled, and we left only with cosine theta that is equal to 1 over 2 times square root of 2 minus square root of 3. Our mission is to find out the value of theta itself. In order to find out the value of theta itself, we operated the opposite function of cosine, that is cosine minus 1, on the result. This is this expression. In this way, we got the value of theta itself. Again, we operated the opposite function of cosine, that is cosine minus 1, on 1 over 2 times square root of 2 on square root of 3. In this way, we got the value of theta itself. And if we operate the opposite function of cosine, that is cosine minus 1 on 1 over 2 times square root of 2 minus square root of 3, we'll get that this expression equals to 24.203 degrees. So in conclusion, we found out that the size of angle theta is equal to 24.203 degrees. Here the size of this angle theta is equal to 24.203 degrees. Okay, thank you very much.